All right, so when we think about circuit analysis, we need to think about a couple of things. So the first thing is we need to talk about how we're going to draw our circuit elements. So let's just draw a simple circuit here. So that's going to be our wire. Batteries will be long and short lines like so. The long side is the plus side, the short side is the minus side. Wires come out. Then resistors are basically just going to be zigzaggy lines here like that. Okay, so I'm just going to draw a simple circle here. Okay, now, so we'll call this one R1, this one R2, and then this one R3. All right. Then this is going to be V1, or sometimes you'll see it written as E1, depending on what kind of problem you're doing. All right. So I want to analyze this circuit. I'm going to start this with either series or parallel circuit. So I need to decide if this one is series or if it's parallel. So what I do is I think about current flow, and I say to myself, okay, the current's going to flow out of the plus side of the battery, and it's going to try to get to the minus side. So if I look at this particular picture, the only way that it can go is if it comes out of this side, it has to flow around this way. Corners don't matter. It's going to flow through this resistor. It's going to flow through this resistor. It's going to flow through this resistor, and then it's going to come to the negative side. That is the only way that it can traverse that particular circuit. Okay? So if there's only one way to go around the circuit, one way in and one way out, we say that that's a series circuit. Okay? And if you remember, in series, everything gets the same current. So the current through resistor 1 is the same as the current through the resistor 2 and 3. And that's because that's the same as the total current through the battery. There's nowhere else for it to go. Okay? But the voltages add up. So V1 plus V2 plus V3 is equal to V total. And I should call this, instead of V1, I should call this V total right now, because that's the voltage of the battery. Okay? All right. So if I want to analyze this circuit, the first thing I need to do is I need to find the equivalent resistance. Okay? And the equivalent resistance of this particular circuit is, because it's a series circuit, remember it's R total for series is equal to R1 plus R2 plus R3. Okay? Now, let's put some numbers on these just for fun. So let's say that R1 is 10. Now, we haven't talked about the units of resistance, but it's the unit of ohms. It looks like the Greek letter omega. That stands for ohms. Okay. R2, we'll say it's 5 ohms. And then R3, we'll say it's, I don't know. Let's say it's 6 ohms. Okay. So the way I find R total then is I take this and I simply just add up my resistances. So R1 is 10 ohms, R2 is 5 ohms, and R3 is 6 ohms. So my total resistance for this circuit is 21 ohms. What that means is, if I wanted to, I could redraw this same circuit like so, and I could replace all of those resistors with 1 and still have the same battery here. Then I could say that this is R total. Is equal to 21 ohms. And what that means is it would draw exactly the same current out of the battery as the 3 resistors in the top. Okay? Now, the way I can find that current is I can say, if I know, like if I knew the V total, for example. So let's say I know V total. Okay, sorry. So let's say I know that V total, for example, here is, I don't know, we'll say 7 volts. Okay, just making up some numbers. All right. So what that means is down here that this is still 7 volts. Okay, so if I go back and remember Ohm's law says that V is equal to I times R. Now remember, the nice thing about Ohm's law is it's true for the whole circuit or part of the circuit or however you want to do it. So if I wanted to find the total current, then the total current here would just be I total is V total over R total. Let's rearrange in this equation. And so I've got a V total of 7. I've got an R total of 21. And so I would have 1 over 3 or 0.333 repeating. And then the units, which is volts over ohms, is what we call amps or amperes, but it would just be 0.333 amps. Okay, that would be my I total. Now, since this is a series circuit, then I know that if I know that this is a series circuit, remember, the current's the same through everything. So once I know I total, I know the current through all of these. So I know that I1 equals I2 equals I3 equals whatever I got for I total, which is 0.333 amps. Okay. Then I can find the individual voltages. So V total is equal to V1 plus V2 plus V3. But the way I find the individual voltages is I just use Ohm's law again. It's I1 times R1. So I1 is 0.333 amps. And then I'll go back and remember that I said that R1 is 10. So it's 10 ohms. So that's going to be 3.33 volts. Okay. Then V2 would be I2R2. So that's 0.333 amps times 5 ohms. Okay, so that's going to be whatever that is. So a third of 5. You have to work that out on your calculator. And then V3 is going to be I3 times R3. So that's 0.333 amps times 6 ohms. And a third of 6 is 2. So that's 2 volts. So, but I know that these 3 better add up to 7 volts because that's what I had to start with. Okay. All right. So now, the way we draw parallel circuits, it looks a little bit more like this. So I've still got my same battery. But now the current has multiple paths it can take. So one way I can draw that is like this. So here's one resistor, or I can go on down and go to another resistor, or I can go on down and go to another resistor, like that. Okay. So this is still going to be V total. This is going to be R1. This is going to be R2. This is going to be R3. Okay. Let's make this one 5. This one 10. And let's make this one 20, just for fun. Okay. So now what happens is when the current comes out of the positive side, because remember the long side is the plus side and the short side is the minus side, the current's going to come out, and right here it's still I total. But when it gets to this junction right here, some of it can go this way, or it can come down here and some can go this way, or it can come down here and some can go this way. And then they're all going to meet back up here and go back into the battery. So here I'm going to have different currents through each one of these. Kind of squash that in there, but that's okay. Okay, so remember, in parallel, the voltage is the same across each one. And you'll notice here that the voltage is the same. Okay, so remember, in series, or excuse me, in parallel, notice how this battery is connected across each one of these. I could remove any of these resistors and the battery would still be connected across each individual resistor. So remember, that means that V total is equal to V1 or V2. It's like they're all hooked directly to that battery. But the currents have to add up because they split up and go through the individual pieces. Okay? So whatever V total is, we'll say it's, oh, I don't know. Let's say it's 100 volts this time, okay? So what that means is if V total is 100 volts, that means V1 equals V2 equals V3. They're all 100 volts. But their currents are going to be different, okay? So I can figure out what the currents are based on the resistances, okay? So the first thing I can do is I can take this and I can break it down into one, or I can combine it into one resistance. So if I remember, my rule for my parallel resistance is 1 over R total for parallel is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so this is 1 over R total parallel is equal to 1 over 5 plus 1 over 10 plus 1 over 20. Now, I like to do fractions here because I can get a common denominator. So 1 over 5 is 4 over 20. 1 over 10 is 2 over 20. And then this is 1 over 20. So that's going to be 7 over 20. So our total is going to be 20 divided by 7, which is not quite 3 ohms. Okay, so we can work that out if we really feel like we need to and figure out what that is. Let's see, 20 divided by 7 is 2.85 or 2.86. So the R total is R total is 2.86 ohms. So what that means is I could replace this circuit here with one where I have a single resistor equal to that equivalent resistance, and it would draw the same current out of the battery. Okay. All right. So what that means is I could find I total if I wanted to. So I know that, V total was 100 volts. Okay. So I can find I total, again, is V total over R total. So it's 100 volts divided by 2.86 ohms. And I total is about 35 amps. Okay. So now what I can do is I can go back to my individual ones and I can say, okay, well, V1 is equal to I1 R1. So I1 is V over R. Okay. So if I know they're all the same voltage, so that's 100 volts divided by R1, which I have to go back and remember what it was. I think it was 5. Okay. So that's just 100 divided by 5, which is easy enough. It's 20. I can do the same thing for the other two. Well, actually, let's not even bother writing that out. We'll just do I2 is V2 over R2. So that's 100 divided by 10, which is 10. And we'll do I3 is V3 over R3. And that is 100 divided by 20, which is 5. And these better all add up to I total, which is 35. And they do. So good. Okay, so that's a simple analysis of a series and parallel circuit.